All right, welcome back, everyone. In the previous video, there was a lot of discussion of sampling techniques, but there was also some discussion of things of how to do some different things in Excel. Though most of what you needed to know was in the previous video, in this video, I want to somewhat address some of the things that I might have missed or some of the other details that I think are important in these first few sections that I wanted to make sure I mentioned to you guys as well. So this is going to be a bit of a compressed version of what was missing from the previous video. With that stated, we talked a bit about sampling techniques in the other video. In this video, we're going to particularly talk about types of data. There are at least two different types of data. We're going to find ways to classify them into different groups and then talk about them. And you'll discuss these some in an assignment this week. So I think that this will help with that assignment very much. So first of all, let's talk about the different types of variables that there are. The first type out of the two are called qualitative variables. Okay? These are variables that measure categories, some characteristic or attribute about something in a population. So hair color, particular soft drink brands, even something like a jersey number in a sports team, right? This would be a categorical variable, or it would be a qualitative variable because the number doesn't really represent anything. It's numerical, but that number doesn't represent anything that we actually measured. It just represents a person, right? And that person would be a distinct characteristic. It'd be different from another person. Quantitative variables are things that can be counted or measured, right? These are things that are numbers, numerical values that mean something. And so, for example, we can measure the distance that a frog jumps, right? Or we can count the number of frogs. Right? Or we can even pick up a frog and measure its temperature with a thermometer, right? All of these things would be quantitative measurements, numerical measurements that we can compare to other numerical measurements. Now, most statistical tests require that variables are quantitative. We're going to talk a bit about how to analyze some qualitative information throughout the semester, but we'll mostly talk about quantitative results. We can break down quantitative variables into, again, two different types. The first type are discrete variables. These are things that can be counted, and they're essentially indivisible, things that are whole numbers, right? So we can count the number of frogs, right? We can count the number of basketball goals scored in a game, or we can count the number of tomato plants in a garden, right? But in all those cases, none of those things will have decimals, right? We can't have 0.5 frogs in a contest, right? We can't have 0.5 plants in a garden, right? Either we have one plant or we have 0 plants. And so these would be discrete variables. They're indivisible in terms that you can't represent them with decimals. And these are things that only take on counting numbers. And you can't score half of a basketball goal. On the other hand, continuous variables can assume some infinite number of values. Right? In the survey that you'll respond to this week with the assignment that you'll do, I'll ask for your height in inches. And your height in inches could be any number. Right? It can be represented by any decimal. And if we went and measured everyone's height, those decimals would likely all be very different. Okay? And so continuous variables can represent an infinite number of values, right? All the decimal places, right? So the distance that a frog can jump, well, it could jump 1 foot, it could jump 2 feet, but it could also jump 1.5 or 1.25 or any distance in between. And the same thing with the temperature and the weight. These can all be represented by decimals. Some of the variables that we use in statistical tests can be discrete variables, but we'll kind of treat them like they're continuous, right? So in a way, when we talk about averages later, right, we can talk about the average points scored by a basketball team per game, and we can use a decimal place to talk about that. We can say that they score about 110.5 points per game. That tells us that it's usually between 110 and 111, right? But that value represents something that we can understand. Okay? Even though we know they can't score exactly 110.5 in a particular game. Right? That average still somewhat makes sense. And so sometimes we can use discrete variables and allow the decimal points to make a little more sense. Whether a variable is quantitative or qualitative determines essentially its level of measurement, but that's not the only pieces that can come from these types of variables. We can measure questions or ask questions in different ways, right? And each way that we ask the question can change the way that we get our answers. So if we go back to height, I could ask you whether you are in a particular range of heights, or I could ask for a specific number. If, for example, when I ask for your age on the survey, I expect a whole number, though most people could probably report some decimal. Okay? And so these things determine what's called the level of measurement, the way that we ask questions. Okay? And this is going to be important to understanding this assignment this week. And at the same time, I'm going to talk to you about how to visualize these different things, because the visualizations that you use for this data is directly dependent upon the level of measurement. It's determined by what you measured. So let's start with the simplest case, which are nominal levels of measurements. Okay, these are data that can be broken down into mutually exclusive, right? So non-overlapping categories. Okay, but we can't rank these categories in any particular way. I have a bad habit of calling these categorical variables. Okay, but these are things that we really can't compare to one another, right? But we can really, we can talk about, whether we like one more than the other. So for example, if we're talking about something like the color of a car, right? Or a particular soft drink brand, right? If we just go with the Coke or Pepsi question, okay, we could ask people and get their opinions, but we can't numerically, right, with numbers, compare the two. We either just have Coke or Pepsi, right? You're either one or the other, okay? And so we can't rank them in any kind of way. But there's no order or ranking to soft drinks in that particular way if you're asking someone their favorite soft drink. Okay, so nominal measurements are categorical measurements. They're just categories, okay, things that we break down into categories. When we do this, nominal measurements, we can use them, we can visualize nominal measurements using things like pie charts. Okay, pie charts will show the breakdown of the percentage in each group, right? Or the percentage that has that's fallen into each piece of the pie, right? They're often used for nominal data to show how they relate to one another. And you'll do this in one of your assignments here in a few weeks. Now, I believe I talked about some of these visualizations in the previous video, so I don't want to get into too much information about it. If I missed something or you have questions about something, please ask. But I do want to always point out that be careful when you do this in Excel and don't include the total column in your Excel chart, right? Because then you wind up with this piece on the side here that you don't need. Okay, so make sure that you're not including those totals. The pie itself represents the total. And then each of the categories make up that total. You should see something similar to this. And we can also talk about how to find the degrees in each pie chart, but also the relative frequency in each of these pieces of pie. Once again, I believe when I discussed frequency distributions in the previous video, I talked about this. Okay, but we would just take, to calculate the relative frequency, we would just take the number in each group and divide by the total, right? 8/62 is going to give you a decimal 0.129, so on. Okay, or 12.9% is in that group, right? In this case, I think they round it to 13. One step above nominal measurements are ordinal measurements. Ordinal measurements are things we can classify into categories and we can rank them, but there aren't really precise differences between them. And my favorite example for ordinal measurements are t-shirt size. If you buy a t-shirt from one company that's an extra large and then buy a t-shirt from another company that's an extra large, those two shirts could be completely different in completely different sizes. right? And the reason is because two different companies made them. We can't compare those two shirts to one another. We can only put them in order with other shirts like them. Right? We can only put them in order with other shirts from that one group. We can only rank them. We can't compare them across different groups. Okay, and so ordinal levels of measurement are things that we can rank, but we can't compare them to one another. Okay, so similarly, when we talk about Likert scale questions, okay, which are strongly disagree to strongly agree questions, the questions you see on surveys all of the time. Those types of questions, we can measure the number of people who disagree and agree, but there's no definitive way to determine, some type of way to measure exactly how much is between disagree and agree, right? Every person is different, so we really can't compare the persons to one another. Right? We can only kind of count and see how many people respond in that way. Okay? And in that way, the counts matter. Right? And so when we talk about ordinal measurements, we generally use things like bar graphs. Okay? Grades could be nominal measurements or ordinal measurements, generally ordinal. Okay? Because we can order them in some kind of way. We can rank them. Right? We can put them in an order. And you would use a bar graph for ordinal measurements. Now, bar graphs are often used for other types of measurements, and it's not really the appropriate thing to do. So remember, if it's not a category that's ranked, you probably shouldn't be using a bar graph. Be careful with that. And so if we want to talk about which level of measurement would be a customer satisfaction survey, I said this just a few minutes ago. Maybe if you want to quiz yourself real quick, just take a second and think about the answer. But here, we would have an ordinal type of measurement. We can rank agree and disagree, or strongly agree and strongly disagree. Okay. But we really can't compare agree and disagree to each person individually. Right? Everyone's going to have a different level of agree and disagree. When we talk about quantitative measurements, right, so nominal and ordinal measurements are qualitative measurements. They're categories. They're things we can either rank or not, but they're categories. When we talk about quantitative measurements, the first type we can talk about are interval levels of measurements. Okay? Interval measurements have precise differences between each of the values. Okay, but the main thing here is we don't have any type of real zero that's represented in that measurement. Okay? And this really takes a little bit of thought sometimes. Right? So for example, IQ score, if you were to measure the IQ score of everyone, there is no real zero on an IQ test. Okay? That doesn't measure anything. Okay? You could have a really low IQ or really high IQ, but you're not going to have zero. I often joke with my classes that if you could have a credit score that was zero, I would have it. Okay? Because it's, it can be bad, but it can never be zero. The same thing is basically with your SAT or ACT scores. Okay, those things those zeros won't really happen. They don't matter. They don't have meaningful zeros. But we can compare IQ scores across people and credit scores, and it tells us something about the data. It tells us something about the measurement. The same is true for temperature measurements, Celsius and Fahrenheit. Those temperature scales, though we can compare them to one another, the zeros imply, in Celsius it implies when water freezes, in Fahrenheit it implies basically nothing. Zero doesn't mean anything special in Fahrenheit. But those zeros aren't meaningful, right? It's not the bottom. You can keep going below that, right? We have Celsius and Fahrenheit temperatures below zero. The next level above interval measurements of quantitative variables are ratio measurements. And these are the same as interval measurements, but there's actually a true zero. Okay? Here, zero matters and it can happen and it can exist. Okay? When you have ratios in this way, right, you can have ratios between the numbers in a particular population, right? So we can talk about having 0 Instagram followers, but 2,000 Instagram followers is also 2 times 1,000 Instagram followers, right? So that math works. Okay. Distance. We can travel 0 distance, right? And that means something. It just means you didn't move, right? You can have 0 weight. In some cases, it might be for which it might be the question coming up, but it might be for something like an astronaut who is weightless, right? Or it could just be something that is a really, really light weight that's very close to not having any weight. Right? So like a feather or something like that, a really small value. And for the same thing, Kelvin temperature scales do have a true zero. It's absolute zero. It's the point where motion stops. There are no temperature measurements below that. Right? So that zero means something. Okay? And so in interval and ratio data, much like with quantitative data, we can compare values across multiple samples of people and different samples. Right? We can find the average number of Instagram followers for groups of people and talk about the differences between them, the average distance that people travel to school or to work every day, and talk about the differences between them. Right? But we can't talk about the differences, the mathematical differences between everybody's favorite T-shirt size or something like, or extra large T-shirts in different places. It's a lot. You can't discuss those types of things. So one way that we can show interval data is by using a stem and leaf plot. Now, I believe that I did do some of this in the other video, so I'm going to kind of briefly go through this. Okay, but remember that in a stem and leaf plot, we're just going to break down the stem, which is in some cases, depending on the values, you're going to take the first number, in this case, the tens place. Okay, we're going to have 7, 8, and 9. And then we can write the leaves, which are each of the ones places behind it. 1, 3, 5, 5. And this allows us to get kind of an idea of the distribution of the data as we're looking at it. Okay, but it's not the best visualization that you can use with particular types of data. Okay, and so we can construct another stem and leaf plot. I believe this is in the other video, but it would look something like this here, where we would break down these 20 cardiograms that are put in numerical order. Okay, so starting with the first one, we'll have 0, 2, and then 13 and 14, and we would just write the leaves on each side. Again, I believe that I covered most of this in the previous video. This is one way to show interval data, right? Numerical data. And it gives us an idea of how many 30s are there, how many 40s, how many 20s, right? It gives us an idea of the distribution. Okay, we could find that most of the values fall in the 30s range, right? Which likely implies that the most common value is going to fall there as well. Right? And we're going to talk more about these as we talk about measures of center and things next week. But for now, the idea is just to kind of understand how the data distribute themselves. Okay, stem and leaf plots are great, right? And they show you that distribution. They're not always the best, and they can be a little complicated to make. Let's briefly talk about this. We want to talk about the points scored by basketball players in a game. We want to know the level of measurement there. Well, we know that it's a numerical measurement, and we can compare points in different games. Okay, so the only question is there a true zero? And yes, you can score 0 points in a basketball game, so this would be a ratio variable. Now, another way that you can show distributions of data, very similar to what I showed in the stem and leaf plot, are dot plots. Okay, dot plots just take and put a dot in each of the values, the ranges that we talked about. Okay, and you can see this distribution in somewhat the same way. However, they're kind of tough to do in Excel. Okay, they can be a little challenging to make in this kind of way. I'm not sure if there's an easier way that maybe I've missed over time. In general, dot plots aren't as helpful as some other types of plots, particularly the one that I'm going to show you last. Now, again, I believe that there's a bit about histograms in the previous video, particularly how to do them in Excel and how to do some of the different adjustments. But I just wanted to point out again the importance of histograms when we're looking for data distributions. We're looking at data distributions. A histogram represents the frequency that lands in a particular range, okay, or a particular class or a particular bin. And that just tells us how many people are within that range, right? So if we're talking about the number of cardiograms per day, there are 4 data points between 2 and 20, right? What is this? 9 between 21 and 38, and so on. Histograms are great for showing the distributions of data. Okay, you just have to be kind of careful with them, especially in Excel. And again, I think I mentioned this in the previous video, but if I didn't, okay, the distribution can hide from you. Okay, you want to always adjust the bin width. I know in the previous video I showed you how to do it. I'm not sure if I talked about why. That video was from a previous course, and there are things, I can't remember every little thing that I said in there. But I wanted to make sure that I reiterated this. It's important to change the bin width because it'll change the way that the distribution looks. And the best way that I've found in general is to use a bin size or a bin width that's about half of whatever your standard deviation is. Now, we haven't talked about what the standard deviation is. That's next week. Okay, but you can see much better, a much more normal-ish distribution here with the data, or a much more bell-shaped distribution, if you will, which we're going to talk about in just a second. Okay. Most of the information that I'm giving you here will be useful throughout the course. Okay. So just, statistics is all about building pieces upon one another. We start off with a lot of terms and things at the beginning, and we're going to put it all together into one big idea before it's all over. And we'll be able to use it very often. And so don't worry too much about things like standard deviation, because we'll come back to that. We'll talk about that again. We'll talk about that again a lot, particularly next week. But I do want to briefly show you some things about distributions of data, and what data can look like. Okay. Data can be distributed in all sorts of ways. I've left off a few things that you might otherwise see here and some other random data sets that you find, and I'm going to focus here on the important ones. In particular, this is the most important, which are symmetric or bell-shaped distributions. Okay. Now, again, there's information here about the mean and the median and box plots that we'll discuss later, but I want to just point more to this shape, okay, where you have some center point, okay, and symmetric meaning that it appears to be a mirror image on each side. Okay, that's why we call it a symmetric distribution. We draw a line right down the center. Both sides look like one another. Okay, we can have other types of distributions. Well, here's just another example of a bell-shaped distribution based on some average college data. As you can see, this is somewhat of a real-life example. It won't always match the curve perfectly, but it'll get close, right? And that's kind of what you're looking for in a lot of data that you collect. Once again, we'll talk a lot about these shapes later. I just want to introduce them to you as we go along so you can kind of learn how to talk about them. Okay, we can also have skewed distributions. Skewed distributions just mean they don't look as bell-shaped, but they're skewed just a little bit. Okay, negatively skewed distributions have this type of shape that you see here, for reasons we'll talk about next week. Okay, you can determine if it's negatively skewed based on the mean and the median. Similarly, positively skewed distributions can look like they're pulled a little bit more this way. And you have a similar shape that's of the distribution that you see here. Okay, so just be aware that these different shapes of distributions can exist. Okay, we're going to talk a lot more about these different types as we go through, and you'll have an Excel assignment to practice some of these things with some of the data that we collect from the survey, or some of the same variables. The final thing I just want to mention is what's called a bimodal distribution. Okay, and so this looks kind of like a W or an M, if you will. Right? Okay, here we have groups where we have two values that are the most frequent. Okay, and that would imply two modes, mode being the most frequent value. Okay, we'll talk again about that next week. Okay, but this makes the shape of the distribution a little different. Okay, it's just something to look for as you go along. In this case, hopefully I've covered everything from that I missed in the previous video, particularly about levels of measurement. Okay. In the next video, you will get to see some things about misleading graphs, but I'll also talk about some other things that you might see on the internet. This is a lecture that I gave in a previous course, but I think it's interesting and it'll be helpful to you. Okay, and as we go along, next week you'll see some more videos kind of mixed in from other classes along with these ones that I've made particularly for this class. But if you have any questions, please let me know. Okay, there is an assignment this week where you will complete a survey. Okay, and then you'll take some of the questions and tell me what's the level of measurement of all the questions. Okay, don't worry about remembering the questions. I have them in the assignment, but I want you to take the survey first because we're going to use your data as we go along to do some other assignments. You'll be able to learn something about yourself and your classmates, essentially. And then at the end of the week, there's an Excel assignment that you can start on that will be due next week. That will get some practice with making some of these things in Excel. A lot of what you need from Excel is in the previous video. So if you skipped over that one and just started this one next, make sure you go back to that Excel video and watch all of that information. If you have any questions this week, please let me know. I'll be happy to help. Otherwise, I will see you guys next week. There'll be some new videos for you to watch about measurements of center and measurements of variation, and we'll talk quite a bit about means and standard deviations. You guys have a great week, and I will see you all soon.